Hello and welcome to lesson 2 of week 4. In this lesson, we are going to look at the merge sort algorithm. My name is Mildred. Now, the merge sort algorithm uses the divide and conquer algorithm. Is comparison based, and we achieve this by dividing an array into like two halves, and then we recursively sort each of the array and then merge the two sorted halves into one sorted array. So the implementation of the merge sort is a little straightforward. We'll start by getting a midpoint for an array. So let's say we define let's say the merge sort, and we want to pass in an array here. We want to get the length of the array. So first of all, we want to see if the length of the array is greater than 1. We want to find the middle point of the array. So let's say the midpoint is equal to the length of the array floor 2. So we want to round to the nearest digit when we divide it by 2, like that. Now we want to divide the array into two halves, and we want to store the values in the two halves. So let's do it like this. Let's say we want to have, we'll do it in this if block. Let's say we want to have an array called left. We'll just say L is equal to, so remember your slicing in Python. We want to say start from the beginning and stop at the middle with the midpoint exclusive. So this is mid. This mid here is going to be the index position of the middle or close to the middle item, right, when it does this. Then for the right now, what we'll do now is to start from that mid, because you know this is exclusive, right? So it's going to start from the mid and go to get to the end like this. So this is how we divide it into two. So this holds the left, this holds the right for the division. No sorting has been done yet, but we want to recursively sort this, because what we said is you continue to sort each half until there is nothing left to sort, completely sorted, and then we merge them, right? So which means that we're going to call this merge sort by itself. Whatever we're doing recursion, we can call it by itself. So we'll say merge sort. So we're going to merge sort the left, and we're going to merge sort the right. So we'll say merge sort L and we'll merge sort right. So this will recursively continue the sort. Now we want to merge all of the sorted halves. When this recursively calls itself, this is going to be sorted, this will be sorted. But now that these two are sorted, we want to merge them. Now merging them is like, you don't want to merge them and then it becomes unsorted. You want to merge them and it's sorted, right? So what we'll do now is to define the initial index. Let's say we want the first array, that's the left, to be represented by I. The initial index is 0. So let's say I is equal to 0. Let's say we'll say J be the second array index 0, and then let's say K will now be the merge sub arrays when we merge both of them. All of them are 0. So instead of writing it like this, we can say I equal to J equal to K equal to 0. So we know what they are. These are the indexes that we want for each of the sub arrays and the merge sub arrays. So we want to copy the data to the left and right arrays. So let's say, maybe let's use the while loop. While I is less than, so the initial index is 0. Y is less than the length of the first sub array we have is less than the length of L, the left one. So you can name this anything you want. I just put left and right to make it easy. And J is less than the length of R. We want to compare the elements from the left and the right before we put it in the merge array, right? So we'll say if the item at the ith index of the left sub array is less than the item at the ith index for the right sub array. So it's not going to be I here, it's going to be J, because we used the initial index for the right to be J, left to be I. Okay? So if this is, the left is less than the right, so we want to say the array. So now we're using the index for the merge. So array K will now be equal to the item at the ith index because it's less than the right. But if it's not, we want to reverse it, right? So we'll say else array K will now be equal to what is in the J. So you see how we reversed it. So if the item at the left, at the ith index of the left, is less than the item at the jth index of the right, then you want to say this array K, that is the item at the index for the merged array, should be equal to this. So we just use IJK to represent the initial indexes for first sub array, second sub array, the merge array. Okay, so when we do it this way, we want to increment the value of J. Here when we do this, we want to increment the value of I. It will continue to do this until the condition is no longer true, right? So if this, so here we want to increment the value of J, so we'll say J plus A. Now we've done this, we want to now increment the index of the merge sub array. So now outside here we'll say K plus equal 1. So I hope this is correct. All right, so we'll do K plus equal 1 here, and then we want to now check if any element was left behind. We've done this, so we want to check for the left and then we'll check for the right. So we'll say while I is less than len L, so if there are any remaining elements in that left sub array, we want to add them to the array. So we'll say array K is equal to Li, like that. and then we increment until it's done, right? Plus equal 1, and then we want to check again for the right. So we say while j is less than the length of the right subarray, we want to say array k is equal to the right j, and then we want to increment j plus equal 1, like that. And then now we're going to still increment k here. When we do this, we have to increment both I and k. So we say k plus equal 1, and here we can increment k plus equal 1. I think that's what we are doing, because we are checking if they are remaining and we are adding it to the merge, and so we have to increment all of them. And so now we can now return the sorted array. So we'll say return the sorted array like this. So I think we're on the correct path here. So return the array like that. So let's test this and see. If name equal to main, we want to say, let's do it like the last time. Simple array is equal to, let's say 30, 38, 27, 43, 3, 9, 82, 10, and let's print it. Original array is going to be, and now we'll say sorted array is equal to merge sort simple array, and then we print sorted array. So let's run this, and we have our array not properly sorted, so there's something wrong with our algorithm. So let's trace it back. This while loop is supposed to be out of this. So it's where we did the loop that created the error, because this while loop, this one ends here, and now we're just checking if anything is left behind here. It's not part of this while loop, and that's the reason. And so when we run again, we get it sorted correctly this time. So this is the correct way to do it. So this first part, we try to merge the two arrays, and then we try to check if anything is left behind on the left sub array, and we check for the right sub array, and then we return the array. If it's there, we add it to the merge array that we have. Okay, and so this is the merge sort algorithm. The time complexity here is going to be better than all others, and the reason is, looks like it remains stable for all cases, whether for the best case, for the average case, for the worst case, and to remain the same, okay, which is n log n. So far with all our sorting algorithm, we want to say that this merge sort has been the best so far, because it has best worst case scenario. So this is where we end this lesson. We are going to look at other algorithms in next week's lesson.